Okay, hello everyone. Right in this lesson, we're going to talk about acceleration time graphs for kinematics. I realized I did not do acceleration time graphs and they're just as important, so we're going to be analyzing those today. In the AP Physics 1 level, you're only expected to know constant acceleration time graphs, so there's not much to them. However, there are some important things. So if there's constant acceleration, that means the line will be flat. That means the line will be flat. That means that... So this is our acceleration. It's our time. That means the acceleration is constant. So remember how in the presentation we learned about velocity time graphs? So in a velocity time graphs, then the displacement is the area. So in an acceleration time graph, we could easily just use common sense to find out the velocity of the object at that time will also be the area. So let's say you're constantly accelerating. This will be your area. Sometime t, delta t, and you're at acceleration a. So this is acceleration a. So what is a delta t? All right, so if we're starting from zero velocity, if you're starting at zero velocity, you can use this kinematic equation. And then you can easily notice V naught is 0. That means VF will be A delta T. So we see that VF equals A delta T. Unfortunately, there isn't any way that we can find displacement from this graph. So you can only find velocity. So what we're going to do is, so we have time here, acceleration here. So this is a VT graph. So I'm going to just make a multiple choice question. Okay, so if we have this acceleration time graph here, so we're asked to match it to the corresponding velocity time graph. Okay, so let's look at choice A. So choice A, velocity is constant. Velocity is constant. That means there's zero acceleration. What some people think is flat line means zero. That's not true. It just means the flat line is constant. So for the position time graphs, flat line means constant position or velocity 0. but that just meant constant position. So for the VT graph, it's constant velocity or no acceleration, which we clearly do not see in the AT graph. So which means this choice is out. Choice B, right? Choice B. So choice B, we see this weird curve, this like quadratic equation looking graph. Well, that is not right. And here's why. Over here, velocity is constant. So acceleration must be 0. However, acceleration is constant throughout. So it will be just stay here. So this graph, and I need curved graphs, like indicate an acceleration that is changing, which is not shown by this graph. And this is the same scenario for C. This does not show constant acceleration, so this one's also out. That means the only choice that is left is choice D. And you can see this is a possible scenario. In fact, this is a velocity time graph for free fall, and this is the acceleration graph for free fall. You see, when you throw it up in the air, velocity is positive. However, here, that's where it stops in the air. Then you'll start falling downward, and that's where velocity starts to go downward. So you can see acceleration time graphs are not that hard. They can just be used as a find velocity, and usually acceleration time graphs will just be like a straight line. They will never like have a slant. We don't deal with non-constant acceleration in AP Physics 1. So that is it on constant acceleration. Thank you for watching.